Okay. How many people here have experience with writing unit tests with, let's say, stuff like Jasmine? What else is there? Mocha, Chai, Jest. I'm going to use Jest today, just so you know. Just so you know. You can expect more of that humor for the next 15 minutes. Yes, we paid for this stuff. Okay. So there's unit testing and there's test-driven development. How many people here have tried test-driven development, like literally writing the test before the code? How many people here are actively doing it at work? Yeah, that's what I thought. Okay, can we start? The guy behind, I don't know what you want to do. Okay, sure. We got rid of Twitter, that's good. So hello everybody. My name is Roy. Osherove. I am the author of Art of Unit Testing. I wrote it a long time ago, and then a second version came out. And everyone keeps still asking the same questions, like how do we start doing unit testing, etc. And I realized that you can't just write a book and then expect the world to change. So I started, leading, working as a manager, as a director, started learning about how do we motivate people, how do we change behaviors, and that's the book called Elastic Leadership. And I'm currently working on 2 books. The 3rd edition of Art of Unit Testing, which is going to be written in JavaScript instead of in C#, because I thought, what the hell, I gotta learn JavaScript, and what is the best way to learn JavaScript than to prove to the world that you have no idea about JavaScript by writing a book about it? And that would force me into kind of a pressure, and I love it. I've learned so much about, I used to play with JavaScript all the time, but really getting into it and functional style versus object-oriented style and higher order functions, a lot of that kind of geeky stuff, it's so interesting. And I was wondering whether the same patterns from the original book would hold in the JavaScript world. The good news is that about 80% of them are still true in the JavaScript world. The implementation details are a bit different. And I'm also writing a book called Pipeline Driven, which is all about continuous delivery at enterprise scale. But that's not the talk for us today. So today we're gonna, understand test-driven development. Okay, there's a difference between just showing it versus understanding it. Oh, thank you. Versus understanding why it matters. Why does it actually make a difference? Because we can all know the 3 different rules, right? The red, the green, the refactor. It takes 5 minutes to understand that concept. What's the point of each one? What does it look like in real life? So we're going to use a short demo for a password verifier, which is a small kata that I like to do. I used to have a kata called string calculator, which I still like, but I find that in the JavaScript world, the password verifier feels nicer. So I'll show the beginning of that. And then we'll touch on to common questions. The first common question is, what is TDD? Because there are various meanings of it. And I think that's also where a lot of the, not confusion, but a lot of the misunderstandings and sometimes confrontations happen around the development world. So let me talk to you about the 4 different ways that people see TDD when I talk to them. Some people just say, oh, TDD, that test first. You just write the test first. And that's just the way it is. That's how you treat it. It's a very simple kind of practice. Some people just say, oh, we're test-driven, but they just mean they're test-oriented. They have a lot of tests. If someone in your organization says, oh, we're definitely test-driven, we're doing TDD, but they just mean they write a lot of tests after the code, a lot of people still refer to that as test-driven development. Some people view TDD as a test-driven design, wherein you would let the TDD process dictate the entire design of your system. So basically, you could start with almost 0 design, and TDD will kind of guide you. And I think a great example of that is in the book Growing Object-Oriented Software Guided by Tests, the Goose book. So that book is perfect if you want to learn that type of philosophy. I'm kind of somewhere in the middle. I say to myself that TDD is about developing new features and also getting guidance on design, but it doesn't mean that I start with no design. It means that I do have some design notions. I might go into a session with a whiteboard or even a document or a few diagrams, and I'll start working. But as I progress, I might realize a lot of design mistakes, and I might change my design based on my tests. So it's I would say it's more of a pragmatic nature. I definitely don't try to be a purist about it. I try to be very, very pragmatic. So that's the approach we're going to take today. If you want to understand where TDD came from, where I first heard about it is in a book called Extreme Programming Explained. And in that book, the idea of test-driven development came up as one of the practices in extreme programming, or XP. Today, I would say extreme programming shouldn't be named extreme programming. It should just be named programming. Because XP is, to me, the thing that makes successful agile teams. It is the underlying core practices that teams today are learning the hard way, that they should have been doing all along to actually succeed in working in small iteration, incremental development. So we may not call it that, but slowly and surely the industry is adopting these practices one by one. They're like smuggling XP into SAFe and into all of these huge waterfall-based stuff. We're kind of sneaking things into them. And then there was a great book by Kent Beck called Test-Driven Development by Example. Has anyone read that book, by the way? Still holds true. I still like it. And that's where I learned about it. And then I went to my first team as a team lead, and I said, we are going to do TDD. And of course, we had many, many, many mistakes. We made a lot of mistakes in our tests. Our tests were not maintainable. They were not readable. They cost us a bunch, and we actually had to delete a few tens of percentages of the tests at some point during the project, because when we were working on the tests, we created glue toward the design of our application where we couldn't basically change things. So there's this whole notion of 3 different skills in TDD. That's the way I see it. There are 3 different skills. The first skill is writing good tests, okay? And that has nothing to do with writing them first. You can write really crappy tests first. And I've seen many people do that. You can also write really good tests after the code has been written. So this maintainability, readability, and trust are 3 core principles of good tests. And then there's the skill of writing the tests first, which is a separate skill altogether. And we can learn it separately. We can even practice it separately. And the final skill is design. The design is the thing that I think is the hardest to learn, and we have to practice it slowly throughout our development lifetime. TDD helps understand that there might be design issues, but it does not solve your design skills. I've seen plenty of people with less knowledge about design create bad architectures or hard to maintain or very fragile architectures, and basically blaming the way that they work on the test's requirements. But I feel like every problem can be solved in many different ways in terms of design. And that's one of the things that we have to learn, is that these 3 different skills are the reason why a lot of people don't do TDD, because they start and then they face this huge wall. They have to learn how to write the test first, they have to learn how to write good tests, and they have to learn about design in a way that they may have not considered before. That's a big challenge to get into. Okay, so let's just get into it very, very quickly. TDD, the 3 main steps, we've all seen it before. Right, the make it fail, make it pass, refactor, red, green, refactor. I've created this kind of short diagram to explain what it really looks like in real life to me. When I work in a TDD fashion, I usually start with the simplest test that proves that something is wrong. Okay, so I try to work very, very incrementally. So I write a test to prove the next small piece of functionality is missing. Could be that a feature is returning the wrong value. It could be that a feature cannot even be callable. Maybe the code doesn't even exist yet. I just prove it. I think of it like a bug. And as soon as I write the test and I get the test to be runnable, that is, maybe some code has to exist for the test to even execute it, but still fail, I should run all the tests, because I want to write the test, but I don't want to have any functionality added except the most basic stuff to get the transpilers working, etc. So all my tests should fail at this point, or at least the first test. And then the next step is to get the test that I just wrote to pass without changing the test. Okay, so I I basically describe this vision of, in a perfect world, I should be able to write a test like this and it should pass. Obviously, the test fails. So then I make it that world that I wish I had by making the test pass in the simplest way possible. Simple, we'll talk about the reasoning for that. The next step is to refactor. Once all the tests are passing, I'll incrementally refactor my code. I'll do one small refactor, and then I'll run all the tests to make sure I didn't break anything. And then maybe I'll repeat that. I'll do a few small refactorings, and for each one of them, I'll continue running the test for each one of them. And I kind of repeat this process until I like the code. Okay? And then I repeat, and I move over to the next functionality. So there are two main loops in TDD the way I see them today. You have the initial loop, which is all about making the code that you trust, so you know the code is actually working. And then the lower loop is code that you like. So if you don't do the refactoring step, what you end up is code that you trust, but you hate. Okay? You're going to get ugly code that works, which is still better than 55% of companies out there, unfortunately, that I've seen. They have ugly code, and they're not even sure that it works. So at least this way, we can refactor if we have the tests. But the refactoring part, this is where, you know, these two skills, this skill of adding the code that you trust, this is, to me, development. TDD, to me, is about driving new functionality. And it's fast. If I don't explain it to people, if I just work with someone or I work alone, TDD is a very, very fast process. You'll see in the demo that it can be fast even when we explain things. But in there, I have two missions, code that I trust and code that I like. And the design skill happens in these locations, as far as I can see. We design, or we understand the design that we'd like to have when we first write the test. When I just write the test and the code doesn't even exist yet, that's where I test my initial assumption of what the design should look like, right? What are the parameters of the function? Do I like the naming, whatever? And I can change things there with basically zero cost because the code doesn't exist yet if I start from scratch. And then I start using it, and during the refactoring, I might refine my design, okay, so that the code is more maintainable and readable. So the design at the top is the functional design. That is, how do we input stuff into the application? How do we change the state of the application? How do we get back some results? Right? What is the path of least resistance for our test to actually invoke? And this design here is about kind of making the thing that's already working, making it something we can be proud of. And that design could be extracting new interfaces, it could be extracting functions into smaller functions, it could be separating to different files, because by the time we get to this lower level, we have code that works, but it might be pretty ugly. So that thing is kind of continuous refactoring that I think about. So if we want to practice TDD, I would recommend TDD katas. Has anyone here practiced one of these katas before, or some other? For those of you that don't know what a kata is, it's taken from the martial arts world. And I think the reason we're using the word kata is because as developers, we all want to feel cool. And so we just want to say we're like the ninja of the whatever. So it's kind of lame, but it's kind of nice too. So let's embrace our geeky and lame behavior and say that we're doing TDD katas. So the nice thing about katas, if we can kind of embrace this idea, is that in a kata you repeat the same thing multiple times, and each time you kind of optimize, you change small things on the way, you get muscle memory on how to do things. At the beginning you do them slower, and you get faster and faster. You get used to them being almost second nature. And to me, that's one of the best ways to practice TDD, because at work, what we usually do is we solve different problems all the time. In katas, you solve the same problem continuously, multiple times, and you look at the way that you solve it as an optimization technique. So we can use katas to learn specific practices. We can even use katas to learn new programming languages. When I switched from C# to Ruby, for example, I did a bunch of katas for learning Ruby, which are basically a bunch of failing tests, and you had to get them passing by getting actual code to run. But because I know how tests work, and the tests were very, very small and functional to test one specific feature of the language, it was a beautiful way to learn. So every time I learned a lesson, a test had become green. It was a wonderful feeling. So if you're looking for learning new languages, look for TDD koans, K-O-A-N. And there's a bunch of them for different languages. The one we're going to use is password verifier. Let's just kind of jump into a demo. This demo, just to show the way TDD works, is going to be about password verification. And I find password verification nice because in terms of design, there are many ways to solve this. And I start with this kind of initial requirement for a design. It might change later on, but I do know that I want something that kind of looks like this. I want a verify pass function. It takes an input, which is a string, which is the password to verify, and a set of rules. And the rules, at this point, they're just a bunch of rules, and if one of them is returning false, then basically our password should fail. And this verify pass is returning true or false. So it looks like it's a very, very simple kind of thing, but we can make it more and more complicated as the requirements grow. Why don't we just switch to this? So my editor of choice here is IntelliJ. I know that many people here see this and say, why isn't he using VS Code or whatever? I like them both, as a friend. But I find sometimes the refactorings in IntelliJ are kind of a bit more powerful. Okay, so the first thing we want to do, the first thing we want to realize when we're talking about TDD, remember the first steps, right? Make it fail, make it pass, refactor. If we're starting new code in TDD, this is kind of what where we're staring at. I want to write this verifier, and now what? It's like an author looking at a blank page. It's like, okay, I don't know what to do. If I was doing this traditionally, my initial thought is, okay, just declare a function, right? Declare a function called verify pass, and then add some tests to it. That's kind of the, let's call it the classic traditional way. But in a TDD way, I wouldn't even touch this file first. I would actually go to the spec file. I'll create a spec file, and I'll write the test before I even write any code here. So if you think about it, the first rule is you don't write extra functionality in the code without a failing test. Basically, our production code is read-only until we have a failing test. Production code, by the way, does anyone know what is the definition of production code in our little demo? What is production code? It's any code that's not tests, okay? Production code is any code that is not tests. It's code that eventually will make it to production. So if I want to start working on verifier, my first instinct is to open the spec file. So I created an empty spec file especially for this group of fine people. And the first thing I want to do is, of course, can anyone tell me? Beta testing. Okay. Which test should we write? Let's start. If I'm not even sure, I'm not even going to do requires or anything. By the way, I'm not using TypeScript for this demo. I'm using pure vanilla ES 2015 because I find it just creates extra noise with all the transpilers, etc. But you can take it to whatever platform you're working on. So the first thing I do is I'll write a quick describe block. Let me just make this a bit bigger. Is it readable? Okay. So the first describe block is usually describing the name of a feature or the name of an entry point somewhere in the code that I would like to test. Now in this case, the feature seems pretty simple. It's verify pass. That is the entry point. And an entry point in my tests is the thing where the execution begins. Because when we're talking about unit testing, we're talking about defining a unit of work. And a unit of work has an entry point and it has exit points. And the entry point is where our test invokes it for the first time and the path of execution begins. But the exit point could either be by a return value. It could also be an exit point where we change the state of the system. So maybe the function doesn't even return anything. And it could be a third party, like sending stuff to a log file or sending emails or whatever. In fact, one function can have multiple exit points. Okay? But in our case, we have to describe where the entry point is. So it could be the name of a function. It could be the name of a feature. I still like to use the name of a function, even though sometimes, because the function is public, it's less likely to change names. But if that happens, then worst case scenario, I'll change one describe. So verify pass. Now, I'm using jest, and in jest you can have either it or test. It doesn't matter. I used to be in a very in simple camp that would say, don't just do describe, do a nested describe like this that says, okay, for verify pass, I will do a describe for a scenario, which is, okay, what is the first scenario I would like to test? Let's say no rules, because that's the simplest scenario I can think of. But we can test this verify pass with multiple different scenarios. I would say no rules, right? And then here I might have an it or a test, which would end up with kind of 3 pieces of information: the entry point, the scenario, and the expected behavior. And I find that these 3 pieces of information are the things that I'm looking for when I'm trying to understand a test without looking at the code for the test. So making the test names readable is a core part of making our code maintainable, because if we can't understand it, we can't maintain it. But for simple tests, I won't even do this. I'll just do like a simple test like this, and I'll put a couple of information points here. For example, with no rules, and I'll put a comma here. I know some people are not crazy about that. No rules, what should it do? It passes, right? Yeah, it passes. Okay, so this is the beginning. This is where I'm thinking about different scenarios. I haven't thought about design yet. I just have to actually start writing something. So what if we do this? Const result equals verify pass. Notice I'm just using the function as if it already exists. I haven't required it yet, etc. And I'll explain why in a second. Now, what value should I send to it as the input password? Any ideas? Sorry? Empty string, what else? Sorry? You are a real task force? Oh, my real password. Okay. No, another one of dad jokes. That's one of what happens when you have 3 kids. Okay, my real password, nice to meet. Okay, whatever. So here's the thing, you were all wrong. So what we'll do is we want to give an input that forces the reader of our tests to not ask any questions. They'll just understand. And one of the important things about tests is to explain to the reader what is not important. Now, what is important is that there are no rules. If there are no rules, it doesn't matter what the input is. Do we agree on that? So I'll just write any input. In fact, when you write tests, I highly encourage it to imagine that the person who's going to read your tests is a serial killer that knows where you live. Okay? You do not want them to ask unnecessary questions. And if I put here, let's say 42, which some of you might want to tell me at some point, then not everyone has read that book. In fact, some people in this audience already are like, 42, that looks like a nice number, but why? What's so important about 42? In fact, let's do it 37. Why 37? Nobody knows. Nobody will ever know. The person who wrote this test left the company a year ago. 37 must be important. What happens when we think something is important? We duplicate it in our own tests. So suddenly you see 37 in hundreds of tests across the universe. Why 37? Well, the elders have told me this is the magic number required to make the right inputs into the application. You find the elder, they're like, nah, I was drunk. What do you want from me? No. So we do not want magic inputs. We just say any input and an empty set of rules. Okay, so far so good. Did I forget something? Something is wrong here, right? Oh, I'm missing the function. And then we'll just do an expect result to be truthy. I hate this name. To be truthy. But it is kind of a JavaScript thing, I guess. Are we missing something? I do have a spare parentheses, right? In line 7. Delete. Now, by the way, I just want to tell you, this guy, he knows, he understands pair programming. He just goes, dude, line 7, right? Because what are you going to do? Am I going to actually read the own code, the code that I wrote? No. It's already legacy code as I write it. Okay, verify pass. Okay, so Now, this is the fun part. Do I like this design or not? Because some of you are looking at this and you have some experience in JavaScript and you're like, no, I would never write verify pass like this. I'd write something like a higher order function that is like const verify pass equals make verifier that takes the empty set of rules. And then here, I do something like this. So I would configure the rules before I get the function, and the function already has rules. Okay, now notice that I just changed the design of my application and there was 0 cost because the code doesn't exist yet. It's so much fun. Now I get to try it. I get to see, do I like this? Do I like this kind of pattern? Is it readable to me? Do I want to change it in some other way? Maybe I need extra parameters. And as soon as I like the test, that's when I commit it to kind of to actual existence by actually making it pass. So for the purposes of this demo, I'm going to keep it very, very simple. But in your own personal lives and your own personal passions of higher order functions and whatever you want to do, go crazy. As long as you write the test first with that design and decide that you like it. So if I like this, I can just go ahead and say const verify pass equals require what was it? Verify.js. Okay, and then I would go to verify.js and make this test pass. Now, I'm going to use for the test runner. I'm just going to use Wallaby. I think it's a very nice test runner, but you can also use Jest and with the watch parameters. I like Wallaby because it shows me very, very quickly errors in my code and coverage, etc. And I can already see there's a type error. Verify pass is not a function, which totally makes sense because verifier doesn't exist yet. So let me just put this here on the right and write this verifier. Module exports verify pass. So far so good. And you can see already that I'm getting kind of a, this line was working, this line was working, this line, major issue. And I can see the error right here, so I get very, very fast feedback, which when I'm working on TDD, should I make the font bigger? When I'm working on TDD, it's definitely something I want. I want very, very quick feedback because I want to move fast. Okay, so what else? Const verify pass. So difficult to type things in front of people. Okay, verify pass equals what? We have an input and rules, right? Yes, I know you're missing TypeScript at this point, but it doesn't matter. Equals this one. You know what? We can actually just return like false. Okay. So what happened here? I returned false because I want it to feel like a bug, right? I want the test to run, and I want the test to fail, and I want it to feel like a bug, and that's kind of the first rule of TDD. I want the first, when I write a test, I want to see it fail before I see it pass. What's the reason for this? I mean, technically, I could just send in and actually parse stuff and do whatever I needed. What's the reason for this? Okay, proof that the test has value, proving that the test is actually good. And that's one of the things that I like about TDD, is that in TDD, I actually test the test, right? Because if I wrote the test after and it passed, how would I know that it would fail when it needs to? And in TDD, I get to see it fail when it needs to, and then without touching the test, it should magically pass when I get the production code to a specific situation. So I test my test, and that brings me trust. If I don't trust my tests, what happens? Let's say that my tests pass and I don't trust them. My next inclination is to debug the code anyway just to make sure to manually test stuff. What happens if my tests fail and I don't trust them? Then you hear the dreaded sentence, don't worry about it. It's okay. It only fails every third time on the first moon of the, and only if you're in like Swedish, whatever. Okay, so we don't trust the test. And suddenly when a test actually fails for a real bug, we don't trust it, and we fail to see. So I want my tests, when they fail in unit test, when they fail, I want to actually feel frightened, annoyed. Not frightened, but you know, kind of worried. Something's red, I feel like I should do something about it. So that's the first reason that I like to do TDD, is that I test my tests. So Now I get to go to the second stage, which is getting all my tests to pass in the simplest way possible, right? Could be a very naive way, but it still has to change the functionality in some way. So, what is the simplest way to change my production code and getting all the tests to pass? No speakers allowed. Make it true. Okay. What's your name, sir? Yitis? Okay. So Yitis said, make it true. So my question to Yitis is this how you write code in your company? We're all screwed if this is what happens. Just to make you happy, I'm going to make it true. Now you can see that everything turns green. And in my head, right, I'm going like, oh, obviously I've done an amazing job here. And this is where TDD fails us yet again. Look what you made me do, Roy. Is this a code that I can be proud of? No. Can I refactor this? Oh, I can return a class that returns an object that returns true? No. Okay, so this sucks. We all agree this sucks. Thanks, Edith. However, I would love to change this because it sucks. I can't. Because the first rule of TDD states, you can't change functionality without a failing test. So if I want to change this because it sucks, I can't. I have to write a new test that fails that proves that it sucks. Okay? So now I've first forced myself to write a new test that says, not so fast, buddy. True is not good enough. So let's do that. Okay? So think of it like right brain and left brain. So now I have to write a test that proves that my code sucks. So what is the simplest test to prove that this code sucks? Any ideas? No rules fails? Okay, so tell me, in the real world, would you have two tests passing where one of them is no rules passes and no rules fails? And frankly, we will find that type of code in the real world. I don't know, parallelism, whatever. So what is a test that should be true in the real world while the first test is still true as well, right? The simplest test, right? If I said, look, no rules, it passes. And I'm like, yeah, sure. That means it always passes, right? Then what do I have to prove? I have to prove that no, sometimes it doesn't pass. So what's the best way to prove it? Come on, anyone give me an idea? Okay, we definitely have to send a rule. Okay, so let's do that. So we definitely need a rule here. Let's do that. Should it be a failing or a passing rule? It is. What? Failing? Are you sure? 2 points. Just for being so brave, I appreciate you. As a friend. So one failed rule. What should happen? Come on, not Yiris. It fails. Come on, people. Developers. Okay, verify pass, any input. Now, obviously here, we have sent an empty amount, right? And here we want to send a single rule. So in this case, a rule can be, we get an input and we just return false. There's no other reason to send it. And of course, this has to be falsy. Another amazing name developed. Okay. Let's make this font a bit bigger, smaller, one a bit bigger. Okay, so now we can see this test is failing. I can see the error here. I can go to production. I can see that it's failing. I can see received true when it was actually expected to be false. So now I can go ahead and say, you know what? Okay, I can't just coast because I can't be the laziest developer in the world and still get all the tests passing. I actually have to do something. So you know what? We can do something like this. If rules length, and of course you have your own implementation in your head, right? Equals 0, return true. Otherwise, sorry? Wait, I did. What's your name? Is your name Will I Regret That? It's going to be okay. I will never embarrass you any more than I embarrass myself. So yes, you might regret it. Well, no, I'm just kidding. You get 2 points because you have given me the right answer. Because in my brain, there are two halves now. There's the laziest developer in the world that just wants to go home, get all the tests passing. And then there's the strict developers like, you missed a spot, okay? So I'm the laziest developer. Return false. Jesus, that's crappy code. Unfortunately, all the tests are passing, right? So now the annoying developer gets to say, no, come on, we all know that what you really want to do is, I mean, this code sucks, right? So let me just prove it to you. So how would I prove it? Let's see. We had one failed rule, it fails. So what if we had what? Come on. Yes, one rule that passes. One passing rule passes. So notice I'm like, no, not good enough. Yeah, not good enough to be truthy. Okay, and of course this fails, and I get to go here and say, okay, how do I make all the tests pass now in the simplest way possible? Any ideas? Sorry? I cannot touch the test. I have to get all the tests passing without touching the tests. Input true. Well, again, I don't want to cheat. I want it to actually work. So without cheating on the test. Sorry? Line 18 here. Yeah, so what you're saying is that it should be returning. Yeah, it should be a passing rule. Oh. Wait, hold on. This is an interesting situation. Let's keep the bug in the test, okay? Screw all of you, I think I'm right. No, hold on. Not yet. Found a bug in my tests. I don't have bug in my tests. You have bug in your tests. No. Okay, so I'll prove to you, okay? Here, it's very simple. Rules 0, sorry, the first rule, and I'm just going to call it with input. There you go. Holy shit, you were right. Okay, so one good reason to do TDD is because I want to test my test, right? And I just tested my test and my test failed. The logic in my test failed, right? Because this should have passed. My test should have done this, right? So now it's green again, but I'm just going to go, okay, return false again because I want to see that my test fails again because now I know my test is correct. And then I'm just going to, okay, that worked. Let's do it. Let's repeat back. And now I got to see my test failing and passing, and I even found a bug in my tests. Okay? So pair programming saved me, but who actually does pair programming? Come on. Okay? I mean, I do it, but most people don't, so they won't find the bug in their test. But this is a good way to find the bugs in your test. Okay, so now we all agree that this code still sucks, right? But now it sucks a little less than previously. In fact, I could say if I had to commit now and push this stuff into production, I have an incrementally working piece of code. I support 0 rules, and I support a single rule. I don't support multiple rules yet, but technically, my code works more than it did before. It's not a 1 or 0 result. So one of the benefits that I find in TDD is that we can very easily create incremental development, micro iterations, if you will. And if my code is always at this kind of ready state, there's always a passing test, there's always only one failing test away from passing, and I can get it passing, then every few minutes, I have a shippable piece of code that I can put in like a feature flag or whatever I want. So far, so good. Let's see. Now I can go ahead and say we can have multiple rules, and I can write a new test for that. But how much more time do we have left? Okay, let's say 10.5 minutes. So we're going to jump in because I want to talk about a few important questions that I had for you. Okay, so some common questions that people ask when I'm sorry. Is this better? Okay, so why do we write the, okay, just for you guys. Why do we write the test before we write the code? Come on. Why do we write the test before we write the code? To see it fail? No, that's that's a different question. Why do we even write the test before the code? To have tests. That's a good answer. So here's my answer. Because otherwise you'll never have time to write them. Okay? If you write them before the code, you always have time to write tests. Isn't life beautiful? Because you don't actually have to ask permission to write tests. You know that, right? To the people in the camera, you know that, right? You don't have to ask permission to write tests. Just like you don't get permission to debug your code, you don't need permission to write tests for your code. If you start with the tests, you get all of these benefits. Geez, I'm sorry. You think through the requirements and you think about the design. And remember that design feeling that we had before? We get all that stuff working. Okay, so my next question is, why do we make it fail first? You wanted to take a picture, right? But if I open the screen, your camera will burn. So why do we make the test fail first? Now is a good time to answer. Sorry? To test the test. That's right. It's test-driven development. Okay? So when the test passes, we are done. Okay? Okay, next question. Remember, we solve things as simple. Okay, I just have to take a picture. She's actually putting on sunglasses. That's awesome. 2 points. Okay, so why do we solve it as simply as possible? Remember that that our design has changed, and our design has forced us to kind of add functionality, but also add tests. Refactoring. We haven't done a lot of refactoring because we didn't get to that point, but probably in the next test I would start doing a bunch of refactors. Working incrementally, we talked about incremental work. Okay, here's another question that someone asked me. Why not just write like 20 tests failing and then solve them one by one? I mean, technically that could work. And as someone who has done that myself, I will tell you that it does work, but it creates a whole new set of problems. Because let's say you have 20 failing tests and you want to make them all pass by not touching them. Our initial human psychology forces us to try to do the smartest thing we can possibly do in production code and try to get as many of them passing at the same time, which basically creates much more complicated code than we need to, and also creates code that has more features than we're actually testing usually. By doing it one by one, I'm forcing myself into a very, very small, narrow loop that forces me to work on one piece of functionality at a time in a very incremental way without complicating my design more than I need to. And the refactoring step will make my design better. Okay, so this is an experiment that I did at a company a few good years ago. And in the company, I was tasked with working with a bunch of development groups on test-driven development. And this company was basically adopting or adapting features to customers of the same kind of infrastructure. And they got to work on 2 different customers with the same adaptation, same requirement for a feature. So we actually had an agreement with the managers to kind of keep metrics on these 2 different groups, because one of them had went through we were consulting for them and we were training them. They had about 3 months experience with the TDD, so they weren't kind of very, very fast, but we wanted kind of to measure. And so were lucky to work on the same type of feature for 2 different customers with 2 different teams. One team was not doing TDD. They were not really doing unit testing too much. They were mostly doing either manual testing or integration testing or a combination of those 2. And of course, there was also a QA team. So what we can see first is that the first line is that the implementation of the code for the team working in TDD was double the amount of time. And it makes sense, because when you work in a test-driven fashion, your 60% of your code can end up being tests. Because for every line of code, there is a test that proves that that line is supposed to be there usually. right? So the implementation took double the amount of time. And then there was this kind of this was a waterfall company. They went through the entire, bug fix and review and change and whatever. And they ended up kind of releasing after 22 days. So just 3 days after the other team was releasing their feature. So now the question was, they ended up, instead of 7 days, they kind of removed 4 days from those 7. Through the bug fixing and the testing, they found less bugs. When they did find bugs, the tests were helping them to find where the bugs are or to recreate the bugs and actually solve them. So then the question is, okay, if it took 3 days more, what did we get for the 3 days? So here's what we found out. The amount of production bugs for the other team on the right was 90% less than the team on the left. Okay, then we had surveys. We were asking teams about confidence and design and API. And basically, we got much happier teams and also happier customers because we got less bugs. Now, when I show this slide in classes when I teach, usually people say, no, you're missing an important part in this process, which is absolutely true. So I removed one part of that process in that company, and that is the integration part. Okay? So in that company, they had what we would call integration or Hell Week. Okay? So because there were many other teams they had to integrate with, there was a lot of code. So usually before you release a feature into customers, there was a Hell Week for integration testing. You work very, very late hours, coffee spilled on the floor, all that good stuff. A lot of fun. So there was still bugs found for integration for the team was on the right, but much less. Okay, they still had integration bugs, but a lot of the time, they actually found that they can either recreate the bugs or they would stop debugging in the logic code and go directly to configuration because the unit tests for the same functionality were passing. So eventually what actually happened is that the team on the right released 2 days earlier than the team on the left. Even though implementation, the coding, right, in a waterfall organization took double the amount of time, the bottom line is they actually released faster because the feedback loops were faster, the fixes were faster. When they had regressions, they could find them faster, and they would fix them as they happened instead of through a manual verification process. So to me, what's scary about TDD is that it's very easy to see the first line, and it's very difficult to see the bottom line, because the bottom line, usually you won't get to this situation where you get to compare. You'll find the bottom line after a few good months of work, if not more, at your company. And by then, it's going to be very difficult to get everyone kind of into that zone, because as a manager, if I see double the amount of time, it feels scary. It makes sense. So we have to realize that that time invested at the top is returned to us in the middle. So it gets reduced, but it's very hard to measure that time in a normal day-to-day work. If you want to find out more resources about TDDs and to look at the kata, if you want to get the first 3 chapters of the upcoming Art of Unit Testing book, go to this link and fill out the form, and I'll promise that I'll send you a download of a PDF for those first 3 chapters, with a promise to send you future emails about when the book actually arrives in full. You can find the more stuff about me and stuff that I teach. I'm actually teaching a workshop tomorrow on TDD in JavaScript for the full day, so I'd love to see you there if you want to join me. And you can find out more about the book and tweet me on Twitter. Thank you very much, everybody. I appreciate you. May the force be with you.